The mathematician Robert Kaplan writes in his book, The Nothing That Is, A Natural History of Zero. If you look at zero, you see nothing. But look through it and you will see the world. For zero brings into focus the great organic sprawl of mathematics. And mathematics in turn, the complex nature of things. From counting to calculating, from estimating the odds of knowing exactly when the tides will crest, the shining tools of mathematics lets us follow the tackling course of everything. And all their parts swing on the smallest of pivots, zero. Welcome to the channel everyone. This is Drone and today we have a very interesting topic at hand. The topic of zero. Before that however, it is time for a quick recap. The last video was an introductory video. In that, the main objectives of the channel were set in terms of the areas of math and physics that I want to explore. We also saw the brilliant example of how the names of the days of the week have Sanskrit origins and how they have been derived from the names of celestial bodies. The theme for today's video, as I said, is zero. Not that of course there are zero themes for today, but that our theme is the number zero. The number zero, or the concept of zero, has probably been one of humanity's most significant discoveries. The funny part is, as you all must be knowing, zero holds no value. In maths, zero is neither positive nor negative. It is neither a composite number nor a prime number. Multiplying anything by zero gives us zero again. So, can we say that zero means nothing? Not really. According to ancient Indian science, zero, or better known as shunya, does not mean void, but means devoid. It generally means that which is indestructible. For that which is imaginary and without boundaries cannot be captured nor destroyed. But it exists, and that is the beauty of the concept of shunya. Confused? Let me explain with some math. We all know the basic uses of zero. When learning about the number system, there must have been some concepts of zero that were mind-boggling. 0 factorial is 1. If 0 indeed meant nothing, this too should have been 0. Log of 0 is again undefined. Any power raised to 0 is also 1. But let's leave all this and come to something even more basic. Division. First, let's divide 0 by a number, that is 0 divided by any number. Now, we know that this is also 0. This is true. By simple rules of multiplication and division, we know that for a by b to be equal to c, c times b should be equal to a. And this is true in the case above. But what about this? Any number divided by 0. Here, the solution is not equal to 0. Many people ask why. The answer to this is not straightforward, simply because it is generally agreed between mathematicians that this is the point where classical mathematics breaks down. To investigate the value of dividing any number by 0, we find the answers for numbers that tend towards 0. We'll start by taking the number 1 in the numerator and then divide it by 1. That answer is 1. Then we replace the 1 in the denominator by 0.1. This number is obviously lesser than 1. However, the quotient is 10. We carry out the similar division for 0.01, 0.001, 0.0001, and so on and so forth. What we can see is that as the values in the denominator tend towards 0, the quotient keeps increasing at an exponential rate. So, is it fair to conclude that 1 by 0 could be infinite? Not quite. While it does follow this trend for the sequence mentioned above, it is very important to look at the other side of the number line, that is, the negative numbers. Again, we'll start by dividing 1 by negative 1. The answer is negative 1. Then we take a greater value, that is minus 0.1. followed by minus 0.01, minus 0.001, minus 0.0001, and again so on and so forth. Here we see that the value of the quotient is exponentially decreasing instead of increasing. So from this we can conclude that 1 by 0 could even be minus infinity. Can you see it? We have a problem over here. 1 by 0 could either be positive infinity or even negative infinity, which completely breaks our laws of multiplication and division. We get a graph like this. This shows us that 0 has no multiplicative inverse, and thus the value is undefined. The point that I'm trying to get through over here is slightly different. Let me come back to the original definition of shunya that I had given. 0 does not mean void, but devoid. It generally means that which is indestructible. For that which is imaginary and without boundaries cannot be captured nor destroyed. Get the meaning now? We may have been saying that 0 in itself does not have any value. But a simple calculation like 1 by 0 shows that 0 can give rise to an infinite set of values both on the positive and negative sides of the number line. Nothing has everything inside it, and everything has nothing inside it. Very different, right? It's incredible to think such a profound concept could have been thought of so many years ago. I mean, it was the 7th century when the Indian mathematician Brahmagupta first used the concept of 0 as a number. He did put forward some rules governing 0, such as stating the sum of 0 with itself as 0 and that the division of a number by 0 is also 0. While the latter part is wrong, as I showed you guys before, the former is correct. Again, note how I say the concept of 0. This is because 0 is not merely a number. 1, 2, 4, 5, 5, 1, 6, 9, 4, etc. All these are numbers. But 0 is far beyond that. Without it, we could not have the number system. We would not have been able to reach space or the depths of the ocean. Even this device that you are watching this video on would not have worked without 0. That's all for today's video. I do hope you enjoyed viewing it. It was a simple concept, of course, but you'll agree when I'm saying that 0 has many more layers of complexity than what meets the eye. The next video will be about time. How it's been defined in ancient books and how it's thought to have multiple dimensions to it. Hope you're excited for that one. Don't forget to like, share and subscribe. Up until next time. Goodbye.